Hey, this is Brian with Radical Prep. We're finishing up this exam, the part 1. We're on 13, and the link for the PDF is in the window below. It says, a laboratory technician studied the population growth of a colony of bacteria. He recorded the number of bacteria every other day as shown in the partial table below. All right, so when I see this table, the first thing I notice is that the numbers are getting pretty huge fast, right? They're getting really big around here at 4. So that tells me I'm probably going to need exponential growth, especially when I'm dealing with bacteria or insect growth. But especially bacteria, the numbers get big fast. So I want an answer that has a variable in the exponent. So 3 is gone and 4 is gone. Now what I'm going to do is I'm going to test the number to see which ones are correct here. At times 0, the number of bacteria should be 25. So let's plug it in. 25 to the 0. Well, we know anything to the 0 equals what? Equals 1. We're not looking for 1 though, we're looking for 25. So that's gone. And if we wanted to, we could test this one. That's 0 plus 1, right? So that's 25 to the 1, which just gives us 25, which is the answer we're looking for, all right? So 2 is the answer to that one. So just plug in and check. It's that easy. Okay, number 14. The quadratic function, or which quadratic function, has the largest maximum? So if you have your TI-84, you can just plug these into the TI-84 and check. Fortunately, I don't have it on me right now. So what I'm going to do it the old-fashioned way, which doesn't really take too much longer. First thing I'm going to do is notice where the maximum is here, right? So it's the highest point, and that's at 1, 2, 3, 4, about 4.5. The maximum here is around there, right? This is just f of x is another way to say y. So that's a max of 9. So that's already higher than this one. So I actually had to go and look online to figure out what was the formula for doing maximums. And the equation was c minus b squared over 4a. So we've got c minus b squared all over 4a is the max. So let's do that for number 3 and figure out what it is. B squared, negative 12 squared is 144. All over 4a, well, that's going to be negative 20. There's a minus there, and c is 4. So basically we're doing, make sure I got this right, yeah. We're doing 4 plus 144 all over 20. And 20 goes into 144. Well, 20 times 7 is 140. So this is like adding 4 and a little bit bigger than 7. So we've got a little bit bigger than 11 here. So this one's gone now because the max is higher for this one. Let's just do this one out real quick. And using our same formula here, we'll try and figure it out. So I'm going to just rewrite this is negative x plus 3. And this is x plus 2. And when we FOIL it, we get negative x squared plus 3x minus 2x. So that's going to be plus x plus 6. So now let's use our formula here that we used before for the other one. So we're going to do, I'll just put a dotted line here so we know we're doing the other one. C is 6 minus b squared is 1 squared all over 4a, negative 4. So we've got basically 6 plus a fourth, which is, 6 1/4, which is not bigger than a little bit bigger than 11. So that's gone. Correct answer is 3. And that's it. Or you can just plug it into the calculator. Sorry, I didn't have a calculator on me, but I guess it's a nice formula to know if you want to find the maximum. All right, 15. F of x is 3 to the x and g of x is 2x plus 5. At what value is the g of x equation bigger? Or the other way to think about it, when is f of x smaller? So I'm just going to pick points here. And I'm going to cheat a little bit to save time, but I'm going to assume 3 is right. Let's test it. Actually, I don't know if that's right. I think it was. So we've got f of negative 3. So that means 3 to the negative 3. Okay. So we got 3 to the negative 3 is going to be 1 over 3 cubed. which is 1 over 27, small number. Let's do the g of x one now. So g of x, g of negative 3 is 2 times negative 3 plus 5, and that's going to be negative 6 plus 5, which is negative 1. Actually, it turns out this one is bigger, right? A 27th is bigger than a negative number. So this is actually not the right answer. So I got to pick another one. Let's go with 1. Let's pick a negative 1. F of negative 1 is 3 to the negative 1, which is just 1 over 3. G of negative 1 is 2 times negative 1 plus 5, which is negative 2 plus 5, which equals 3. And yes, it turns out 3 is bigger than 1/3, so we got to go with number 1 in this case. So in this example, I just picked answers until I got the right answer. And just make sure you know a negative exponent means flip it and raise it to the same power. 3 to the negative 3 is 1 over 3 to the 3. Okay. Let's go to number 16. Beverly did a study this past spring using data she collected from a cafeteria. She recorded data weekly for ice cream sales and soda sales. Beverly found the line of best fit and the correlation coefficient as shown in the diagram below. So if you know anything about graphs, correlation coefficients that are really close to 1 are strong. That means that two variables are associated really, really well. When one happens, the other one seems to happen. Doesn't mean they cause each other, they just kind of happen together. So that being said, this is also a positive correlation. So it looks like as ice cream bars are sold, the number of cans of soda are also sold. Again, correlation does not imply causation. Big technical term you'll hear when you get to college if you take psych classes or anything like that. So what can we assume from the data or the graph? Let's look at number 1. Given the information, which statement can be correctly concluded? Eating more ice cream causes a person to become thirsty. I don't like this word, causes. It's gone. Drinking more soda causes a person to become more hungry. Right? Causes, again. How do I know it's not the other way around? We don't really know what causes the other. We just know they happen together. That's the main idea behind correlation. There is a strong correlation between ice cream sales and soda sales. That is true. Let me X out 2. So I'd only pick 3 in this case. And let's say you didn't know, let's just back up for a second, that 0.96 was a strong correlation. Look at your data. Isn't your data tightly grouped around the line? So that's another sign that you have a strong correlation. So you're just going with number 3 in this case. Number 17. The function v of t is 1350 times 1.017 to the t, represents the value v of t in dollars of a comic book t years after its purchase. The yearly rate of appreciation of the comic book is, well, right off the bat I can tell you the answer is 1.7. Now how did I do that so fast? Well, it's because of my understanding of the decimal places. 1.17 would be a 17% increase. Let me ask you this. What is a 1.64? Could you tell me? That's a 64% increase. Okay. So now 1.01, that is a 1% increase. So anytime you see numbers that are after the 1, okay, there's nothing in the tenths or the tenths position. This is 1%. 0.01 is 1%. So we're looking for 1% and a little bit extra. So it's 1.7%. The other way to think about it, percent means divide by 100. Divide by 100. And the other way of thinking about that is move the decimal place 2 decimal places left. So how does that help us? 1.7%. All we're going to do is go 1, 2. Put your decimal place. Here's a 0. So your answer, 0.017. That's exactly what's going on here, 0.017. 17% goes 1, 2. 17% would be 0.17, which we showed already. That's it. That's all you got to know how to do. Number 18. When directed to solve the quadratic equation by completing the square, Sam arrived at the equation shown here. Which equation could have been the original one? All right, to solve this, all I'm going to do is work this equation out. So that's x minus 5 halves times x minus 5 halves equals 13/4. So that's going to be, and I'm just doing FOIL here, minus 5 halves x minus 5 halves x, and the last terms are going to be positive 25/4, right? 5 times 5, 2 times 2. And that all equals 13/4. So I'll keep simplifying. That's minus 10 halves x. I'm going to minus the 13/4 from both sides. So 25 minus 13 is going to be 12/4. I'm trying to save time here in space, but I would just minus the 13/4 from both sides. So now, x squared minus 5x, right? 10 over 2 is 5. 12 divided by 4 is 3. That's your answer. So now we just got to go and find that. And that is choice 4. That's it. All right, 19. The distance of a free-falling object has traveled can be modeled by the equation d equals 1/2 at squared, where a is acceleration due to gravity and t is the amount of time the object has fallen. What is t in terms of a and d? So basically it's a wordy question that's just asking you get t by itself. That's all it's saying there. So I'm going to write the equation again over on the top here. D equals 1/2 at squared. I want to get rid of the 1/2 a. So to do that, I multiply by the reciprocal. 2 over 1 and 1 over a. And I got to do it to both sides. Sorry, I got a little crammed here. So I'm just going to multiply by 2 and 1 over a. So 1/2 times 2, a times 1 over a. So on the right side, we're left with t squared. On this side, we're left with 2 and d over a. And another way to rewrite that is just 2d over a. A is the only thing in the bottom. Now, I need t by itself. Take the square root, take the square root. Your answer is radical 2d all over a. Well, where's that one? Radical 2d all over a. Okay, that's it. Choice 2. Move on. Number 20. The table below shows the annual salaries for the 24 members of a professional sports team in terms of millions of dollars. Okay, let me take a second to digest this. The team signs an additional player to a contract worth $10 million per year. So that guy, who's that lucky guy who's making $10 million, is going over here. Boop. Right, $10.0 million. Which statement about the median and the mean is true? Okay, I'm going to start with the mean because this is the easiest one to explain. The mean is just the average. So your average is probably going to be somewhere in the middle here, just looking at the data, right? Because this is the lowest, and it goes up, all the way around, and it gets to the highest over here. So it kind of makes sense that your mean or your average is in the middle. Let's say it's 1.42, somewhere around there, maybe even higher. When you add a bigger number all the way to the right, it's going to pull the average up, okay? So the average is definitely going up. So something's going to change, and the average is going to change. So now we got to figure out what happens to the median. We're going to work on the median now. Well, what is the median? The median's the middle number, right? So we could just do this. Eliminate and keep. I know this is the long way, but I'll do it because it's kind of easy to do. So what I'm doing is I'm just eliminating from both sides the largest and smallest number until I get to the middle. And what do you know? I'm left with 1.4 and 1.4. So it's going to be the average of those two. So the median is 1.4. Now when we add 10 here, since there was an even number, there was 24 members, now there's going to be 25. And the median is actually going to move from the middle here. There'll be another number, so it's actually going to move to here. The median moves up 1. If I did this whole knocking numbers off, the median, when you add another number to the right here, it's going to get shifted, I'm pretty sure, to the right. But even if it didn't, and it got shifted to the left, both numbers are 1.4. So actually, the only thing that increases is the average. Choice 3. That's it. That's a tough one. 21. A student is asked to solve the equation 4 times 3x minus 1 squared minus 17 equals 83. And here's the work they do. A correct next step in the problem is what? Well, if you get to this step, the next thing you'd want to do is take the square root. So you should have 3x minus 1 is equal to plus or minus 5. It's that easy. You just got to take the square root of both sides. Yeah, I don't really know how else to explain that. That would be your next step. Okay. Next one. Number 22. 22 says, a pattern of blocks is shown below. If the pattern of blocks continues, which formula could be used to determine the number of blocks in the nth term? So, first of all, I'm going to write down how many blocks are actually in each one. So, in this one, we've got 2 blocks. 4, we got 6. This one we got 4, 8, 9, 10. And this one we have 4, 8, 12, 13, 14. All right, so we know how many blocks are in each term. Now we just got to test the patterns here, right? Number 1 says, it's basically saying, if I want to know what's in the 4th term, I take 4 and add 4 to it, which gives me 8. But that's not true, right? And it seems to only work for the 2nd term. If I want to know what was in the 2nd term, 2 plus 4 is 6. It works for the 2nd one. It doesn't work for the 4th one. So 1 is out. Let's look at 3 because that's easier to understand. If I want to know what's in the 4th one, I do 4 times 4 minus 2. So that's 16 minus 2. That equals 14. That works. Let's just quickly test the others. 3rd one. 4 times 3 is 12. Minus 2 is 10. Good. 2nd one. 4 times 2. The 2nd one is 8. Minus 2 is 6. I'm pretty confident 3 works. So I'm going to keep 3. So if 3 is in, that's gone. We said 1 was gone. So now we just got to test 2. This says if I want to know what's in whichever term, I find out how many are in the one before it, minus 1, and I add 4. So for example, I'll do the work over here. A to the 4 means what's in the 3rd one plus 4. Well, that's true. 10 plus 4 does give you 14. Let's say I was testing the 3rd one. Well, it says what's in the 2nd one plus 4. If I want the 3rd one, I go to the 2nd one and add 4. And that seems to be the case because every one of these is just adding 4. So I'm pretty confident with that one. So it looks like 2 and 3 work as formulas. Answer choice 3. All right, number 23. What are solutions to the equation x squared minus 8x equals 24? Wow, I gotta know quadratic formula, huh? Because I don't have my calculator on me. All right, so let's see here. X squared minus 8x minus 24. And it's negative b plus or minus radical b squared minus 4ac all over 2a. I really hope that's quadratic formula. So I've got 8 plus or minus radical b squared is 64 minus 4 times 1 times negative 24. 4 times 1 times negative 24 all over 2. All right. So it's going to take some work. 8 plus or minus. Radical 64 and 24, 48. That's 96. 24 times 4. So it's 64 plus 96 all over 2. So that's going to be 8 plus or minus radical 160 all over 2. Sorry. Radical 160 we can split into, let's see, what's the best way to do that? I could do, what comes to mind right away is radical 40 and radical 4 all over 2. And that turns into, radical 40 is radical 10 times radical 4, and we still have the other radical 4 all over 2. And then we're going to get 8 plus or minus 4 radical 10 all over 2. And if we put the 2 into both of these, that's going to be 4. I'll just write the answer over here. 4 plus or minus 2 radical 10. Hopefully that's an answer. 4 plus or minus 2 radical 10. Whew. Answer choice 1. I guess if you have a graphing calculator, it's a lot easier. Here's the way you would do it with the quadratic formula. All right. Finally, 24. Natasha is planning a school celebration and wants to have live music and food for everyone who attends. She has found a band that will charge her $750 and a caterer who will provide snacks and drinks for $225 per person. If her goal is to keep the average cost per person between $275 and $325, how many people must attend? Well, this is another case for me where I use the answer choices to help. And it looks like the band is going to charge her $750. So how much it costs per person is going to have to get divided up with the band, right? So let's pick, I don't know, let's pick number 4 here. Assume it's right. So let's say 750 people show up, and then at the most 1,500 people show up. So 750 people. So the band costs $750, but 750 people are splitting it. So that means it's $1 per person. $1 per person, just for the band. And then we got to add the fee of the food and the drinks, which is $225 plus $225, right? So that's a grand total of $325 a person if 750 people show up. All right, so that number looks good because that's in a range. Let's see what happens now when 1,500 people show up. We've got $750 for the band divided by 1,500 people. So that's just twice, $750 times 2. So that's half a dollar. I know I'm going to write it like this, but half a dollar per person or 50 cents a person, right? That's 50 cents per person. And plus, we still have the original $225 per person. All right, so I gotta admit, I cheated a little bit because this one I did beforehand. You'd use the same strategy, but what's nice is that I got it right in the first try. I didn't have to spend a ton of time doing it. Yeah, I cheated because I did this beforehand, but the strategy is the same. Let's say you picked 4 and you got lucky. Well, you got $325 and you got $275. So it looks like that's going to cover the range, right, for the numbers that we picked. If I didn't pick that number 4 first, I could have picked number 2 first. And let's say I picked number 2. The 750 would have worked because it would have given me 325, right? But the problem would have been had I done less people. So now only 325 people show up. What does that do to the amount that people have to share or people have to pay for the cost of the band? You have less people now paying for the band, which means the price goes up. So if you pick this one and you check your numbers, you'll find that it goes from 325 to a higher number because less people are paying for the band. So again, all you do pick an answer choice, assume it's right, and go through the numbers. All right? It's not that bad. All right, keep watching. I got more stuff for you, and you're going to do great on your test. Take care.